All right, welcome to the third video of section 7.2. So in the first video, we looked at functions that were in the form a over x. In the second video, we looked at functions that were in the form a over x minus h. In this one, we're going to look at functions that have both a linear equation for the numerator and a linear equation for the denominator. So these are going to be of the form ax plus b divided by cx plus d. Okay, so we're going to look at functions that fit this form. Now, our steps are the same. First thing you have to do is find the asymptotes, plot them, and then find out your points to the left of the vertical asymptote and to the right of the vertical asymptote. So to find the vertical asymptote, what you have to do is take the denominator and set that equal to 0. So what we have to do, and here our denominator is x minus 3, we have to set x minus 3 equal to 0 and solve for x to get our vertical asymptote. So in this case, we just add 3 to both sides and we get x equals 3. So what that means is if we look at a xy axis, if we go over 1, 2, 3, that means at this line right here, we've got a vertical asymptote. Now, to find the horizontal asymptote, again, you guys should be taking notes for all of this right now so that you have them in class. To find the horizontal asymptote, what you're going to do is the horizontal asymptote is just the line at y equals a over c. And you get these a over c values from your original function. Remember, we're talking about functions that are in this form. Ax plus b divided by cx plus d. Divided by cx plus d. So to get your a and c values, you need to look at your original function. And remember, a is going to be your coefficient in the numerator. C is going to be your coefficient in the denominator. So in this case, we get y equals a over c, which is just y equals 2 over 1, which is equal to 2. So our horizontal asymptote is at 1, 2, at y equals 2. So we're going to have our asymptote look like this. Okay, so those are our two asymptotes. We've got our horizontal at y equals 2 and vertical at x equals 3. Now, to plot this, we're just going to go ahead and take points to the left and to the right of our vertical asymptotes. So if we were going to draw this, we would want to find points at, let's say, x equals 2 and 1 and 0 and negative 1. Those would be good points to find for the left-hand side of our hyperbola. And on the right-hand side, we would want to go ahead and find values to the right of this. So 4, 5, 6, 7. So these would give us a good scattering of points, enough to draw our hyperbolas. So let's look what the graph actually looks like here. So if we go, on Desmos, I've got it graphed for us. And again, you see we have this asymptote at x equals 3. They approach this line but don't hit it. And same thing at y equals 2, we've got our asymptote. So if we go back here, again, we've got 3 and 2, and we've plot our points to the left and to the right of it. Now, for stating the domain and range, remember, our domain is going to be all real numbers except our vertical asymptote, so all real numbers except 3, and our range is going to be all real numbers except the horizontal asymptote, so all real numbers except 2. So our domain and range are limited by whatever our asymptotes are. So remember, x equals is your vertical asymptote, y equals is your horizontal. Your domain is all real numbers except your vertical asymptote, and the range is all real numbers except your horizontal asymptote. So what I want you to do in this one, I want you to state the domain. So look at this and find the asymptotes, and then state the domain and range for this function. So in the answer box, what I want you to do is I want you to write down your two asymptotes, so x equals and y equals, and then I want you to state the domain and range for this function. And that's what you're going to put in, all in the same text box. The vertical asymptote, horizontal asymptote, domain, and range. Make sure you clearly label that in the answer box.